المواعيد عبور الشمس فوق مكة خلال العام 2010 لأزهري محمد.
Thank you, Brother Chairman. Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. Alhamdulillah, Rabbil Alamin. Praise be to Allah Subhanahu wa Taala for the opportunity given to me to be here. My name is Azhari bin Muhammad, and no, I was not educated in University of Azhar, but I was educated in London instead. I work at the Department of Survey and Mapping Malaysia, or in short, it is called JUPEM. This is the building of my department, and I'm in charge of the astronomical activities at my department. And my department acts as a technical agency that is responsible to the Department of Islamic Development, Malaysia, or JAKIM, in providing the following. First, the prayer times, Islamic calendar, moon observational data, direction to Mecca or Qibla, and also some information on the eclipse. And those are the vision, mission, and motto of my department. I'm going to skip this summary. You can read in my paper. And this is the outline of my presentation. So my presentation is basically on how to compute the time and date when the sun would appear above Kaaba, and how to use that knowledge to validate the correct orientation of mosques, especially the mosques that were built long time ago. And the outline of my presentation is as follows. I will give a very brief overview of the common operational techniques of computing or aligning ourselves to the direction of Qibla that is practiced in Malaysia. Next, I will show how the sun transits over Kaaba and how it occurs. Then I will describe to you the computation for the year 2010. It also applies for other years. And then we validate the computation with our own observation. And lastly, I will show you the application of this technique where we will put this into practice. So this is the direction of Qibla from Kuala Lumpur. We have to imagine that there is a tall tower coming from the Earth center, passing through Mecca, and everywhere we stand on the surface of the Earth, if we can see this tower, then that is our Qibla. So we are talking about the spherical triangle, the line connecting our own location to Mecca that is going through the big triangle, the big spherical distance. This is a compass, and for Malaysia, the computed Qibla ranges from 291 degrees to 293 degrees from Malaysia to Mecca. So we are talking about an average of 292 degrees as a figure for the direction of Qibla from Malaysia. And this is I'm going to go very briefly on the Qibla determination techniques that is being applied in Malaysia, and I think it also applied in all over the world. First, we are using the survey equipment. We have the compass, we have the theodolite, we have the total stations, we have the sajadah with the compass right in the middle there. We have the small compass with the book which lists down all the codes number that we can set at the compass to show our direction of Qibla. And the latest one is the use of GPS in actually determining the direction of Qibla. And we also use the gnomon, or the vertical stick, or in Malay we call it tongkat istiwa, where we put a stick in the compound of in the compound of our house, where we mark the morning shadow, and then we also mark on the ground the afternoon shadow. Just joining those lines, just joining those two positions, we can establish an east-west direction. And then by just setting out a right angle triangle on the ground for the Qibla 292 degrees, 30 minutes for 50 seconds, by extending 10 meters from that position and then right angle to it, 4.14 meters, you can get the direction of Qibla on the ground. Next, we also use the Orion constellation. This is the constellation called Orion, the Hunter. One of the most splendid constellation in the sky. You have the bow, you have the sword there, you have the two legs coming out from the center, and then the beauty of this constellation is that there is a 3-star alignment, the Al-Nitaq, the Al-Nilam, and the Mintaka, which points to the direction of the Qibla for Malaysia and its surrounding area. The Polaris, we also use the Polaris, but because Malaysia is near the equator, the location of Polaris is very, very low in the horizon. But we can observe Polaris, so we extend 70 degrees from Polaris, we can get a rough indication of the Qibla, because our direction of Qibla is around 292 degrees. So left of it, 70 degrees of Polaris, we have our Qibla direction. Also, we use the time of sunset. But because of the sunset, it is not constant in the sky or in the horizon, we have to give corrections to the direction and to the position of the setting of the sun. The direction of Qibla is constant for any place, but the setting of the sun moves along with the time. So we must add some correction to it. Say in May, you look at the row number 5. In May, the Qibla is to the right of the setting of the sun by 5 degrees. So we can use the finger. Please forgive me if the finger is rude to you. But the finger, you can extend your finger 5 times, and that will show you the direction of Qibla from the setting of the sun in Malaysia for the month of May. Phases of the moon, we can also locate it. If we can see the shape of the moon phase during the night, we can roughly show that the sun is setting right on the right of the limb of the moon. And then we can use the previous technique to determine the direction of Qibla for Malaysia. And then, of course, this is the most simple one, the spherical triangle. We use this formula to compute, and then we use the total station or the theodolite or the compass to set out our Qibla. And number 8 is the sun at the Kaabah's zenith. This is the topic of my discussion for today. The sun appears overhead Kaabah, and then the shadow cast by a vertical stick will point opposite to the Kaabah. Or for another half part of the earth, we can also compute the position, the time, the date when the sun appeared at the Kaabah's nadir, the point immediately below the Kaabah. We can also do that. And the shadow cast by the stick, vertical stick, will point directly to Kaabah. And then also, we also compute the sun crossing the line of Qibla. This is the direction of Qibla from Kuala Lumpur, Malaysia. Every day, nearly every day of the year, the sun will cross this line. So the challenge now is to compute the date, to compute the times when this happened. So this is a very popular technique. Because it is free, everybody can use it. What we did was we produced the times and the dates when this occurs for everyone who is interested in validating the direction of Qibla of their house, of their mosque, etc. Why are we interested in using this technique, the sun overhead Kaabah? I have been to Batam, Indonesia. The mosque is very beautiful. It was very new, was recently built. But you see the direction of Qibla inside it. It was wrong. It is wrong. it was discovered after so many years that the orientation of the mosque is wrong. I was there, and then I took a photo of the orientation, the mosque orientation. The floor tiles represent the mosque orientation, the blue arrow, while the correct Qibla is in red. So I computed what is the deviation of the angle. It is about 30 degrees, which is equivalent to 4,000 kilometers to the left of Kaaba. I plotted on the map, and it shows that the people in Batam was heading towards Angola, Zambia, and Namibia, and not to the correct place that is in Mecca. And they told me, no wonder their dua is not fulfilled by Allah subhanahu wa ta'ala. Because they have been praying, they have been performing dua to the wrong direction, they told me. And this is another case near my house. The grave, not pointing exactly to the correct Qibla. You see the way it is being oriented, as though it is moving in a form of an arc. So I'm quite worried. If I die, then they will put my grave below there, pointing to opposite direction of the Qibla altogether. Yeah? And this is another case. We would expect the tomb will be aligned perfectly in line towards Kaaba, but not in this case. Okay, so I'm describing to you how it occurs, this sun transit over Kaaba. This is the top view of the Earth-Sun system. I think this is very basic to everybody here. We have the Earth circling the Sun. And then if you look at the side view, we can see this orientation of the whole system. But if we put the axis vertical, then we can see that the orientation of the orbit of the Earth circling the Sun. And if we were to stop the Earth from moving and get the Sun circling the Earth instead, we can have this, which is very simple to describe what is happening. Because the Earth pole is 23.5 degrees, 33.5 degrees deviation from the true vertical, the Sun will appear to circle the Earth with that same angle. So if our country lies between 23.5 degrees north and 23.5 degrees south, then the Sun will appear at one time or another overhead ourselves. So for Kaaba, it will occur in May. Okay. And another occasion will be in July. So this is how you compute it. I think you can read up my paper. You follow the step-by-step computation, then you will get the position or the time and date when this will happen. We already passed May 28, so the next phenomenon will occur on 16 July 2010 at 5:27 in Malaysia or 9:27 in the morning UT time. What happened? Okay, so we validate this computation. We went to two locations in Peninsular Malaysia, and then we compare the observed Qibla and the computed Qibla, and it shows that the computation is conform well to the observed Qibla by just 3 minutes, between 3 minutes and 7 minutes difference. And then we can validate the direction, the Qibla of mosque, especially the old mosque. Because if we were to send surveyors to validate, it will cost a lot of money. So we are providing the mosque officials to validate the mosque themselves, free of charge, without charge or anything. We provide the times and the date, then they go out and validate the mosque. So they just use a piece of rope extended along the mosque orientation, and then wait for that phenomena to happen. And then if the shadow and the mosque are both aligned, then they say that their mosque is in correct orientation towards the Qibla. If there is a deviation, then they will report to the Mufti, and the Mufti will decide whether to orientate the sajadah or not. Yeah? They will not destroy the mosque, no. They will just orientate the sajadah. So in conclusion, we can use this technique to provide an accurate and convenient way to determine the direction of Qibla, and preliminary results show that there are some differences between 3 minutes to 7 minutes differences between the observed and the computed direction, which are negligible. And of course, it is free, but it needs a sunny day. You can do that. So this, I'm going to spend just a few minutes, Mr. Chairman, to make my personal remarks on a few issues that have been raised for the past 2 days. Can I spend just 2 minutes? Yeah, okay. So for the solar times for the Muslim astronauts, I think it is a common knowledge that Malaysia has already sent the first Muslim astronaut to the ISS, and our Malaysian astronaut became the first Muslim astronaut to not only fast in outer space, but also to celebrate the Eidul Fitri in outer space. And we also provide a guideline to him to perform the prayer, and we use the Baikonur in Russia and not Mecca as the coordinate for computing the prayer for computing the prayer times, and the Earth will be its direction of Qibla. And you can get this guideline. It has been translated into many languages for all to use. With regards to the solar times in high latitude places, abnormal zones, I think we cannot escape from mentioning that Hamidullah Islamic Sharia Council in 1982, the Islamic Seminar in the Islamic Cultural Center in London in 1984, they have all come up with a solution for us to follow. So why don't we follow that? Yeah? With regards to the solar times in aeroplanes, we have only 2 choices. Malaysia is considering that. We are going to either adopt the place of departure for computing the solar times, or we are going to use the local coordinates above which the aeroplane flies, with the correction given to the height of the aeroplane. So this is still under consideration, and Dr. Zamri, he's the chairman of this committee. And whether or not we want to use unified or bizonal calendar, gentlemen, I think for us at the Southeast Asia region, we have a government-to-government group comprising of all the religious ministers from Malaysia, from Indonesia, from Brunei, from Singapore, and also representatives from Thailand, Vietnam, and Philippines. We succeeded in accepting a common criteria for the start of Hijri months. So maybe before we discuss at length on whether to accept a unified or bizonal calendar, perhaps we go for a short-term strategy, that is, go for the regional calendar first. Talk to your neighbors. It is not that difficult to talk to your neighbors, to your neighboring countries, and achieve some kind of solution in your region first. Then only we can discuss about having a unified calendar, bizonal or whatever.
Finished time.
Okay. So with that, Mr. Chairman, thank you for giving me this opportunity. Thank you for your kind attention. Also, thank you for Brother Ode and Brother Nadel for giving me this opportunity to come here. Thank you very much.